Hello and welcome everyone who's waiting. I have made a bit of a mistake in that I clicked on the wrong stream. So I was fully going ahead with the lesson on another stream, and there was someone there who was saying the chat was working, and then I couldn't work out why it wasn't working on here. So my hugest apologies for keeping you waiting. I've not done that before, and you would think I would know by now, but I'm really, really sorry for keeping you waiting. And I've said that I will start the session again because we were a few minutes into that. But yeah, apologies for keeping you waiting. Hopefully there's what I'm going to do is just start that again. Let's do that. And go from the top again. Apologies to everyone. Can you now see my screen? Hopefully it's good. Amazing. All right, we start again. So welcome to our session on reciprocal and rational functions. So to warm up a little bit, could you please tell me what is the reciprocal of these numbers, A, B, and C? Please put your answer in the chat. Any ideas? So if we're looking at reciprocals, the reciprocal of 2 over 3 is then 3 over 2. So we're just flipping it on its head. For b minus 5, the reciprocal is just minus 1 over 5, because there's a little divide by 1 that we can turn any number into a fraction there. And for c, we have 3 3/4. So we need to first convert that to an improper fraction. So 3 times 4 is 12 plus 15. 12 plus 3 is 15 over 4. So then when we flip it around, we get 4 over 15. So that's the reciprocals. And take note that I'm not saying negative reciprocal, like when you would have your tangents and normals. So when I'm finding the gradient, like if I have the gradient of a tangent is, let's say, 1 over 4, then the gradient of the normal would be negative 4 over 1. This is a different thing. That's the negative reciprocal because we have the gradient of that line going like that and the gradient of that line going like that. So one's positive, one's negative. But if I say reciprocal, it just means to flip it on its head. So that's where we get reciprocal functions. So if I have a function y equals x, the reciprocal function is just that on its head, reciprocal. So we get y equals 1 over x. We've just flipped it around. So that's what the reciprocal function is. And because of that, we have x being in the denominator. We cannot have a value of 0 there. So while this function didn't have any restrictions on it, this one now has that x cannot be 0 because bad things happen when there is 0 in the denominator. We cannot have that. So they always say x does not equal 0. And that's what gives the asymptote over here of x equals 0. So that's the line x equals 0, and that's the asymptote. So the value that we can't have becomes the asymptote. And now because of that, we also cannot have y being equal to 0. So because of x not ever being equal to 0, that means y will never have a value of 0. So that means we then get this line of y equals 0. That's our other asymptote. So we have this one is our horizontal asymptote, and this one is our vertical asymptote. That these two are very much linked. So this would be our domain and our range, domain and range for y. And the asymptotes are what we cannot have in our domain and range. The asymptotes are. So you can always figure them out together like that. Just some things to note, that the reciprocal function is a self-inverse function. So what that means is 1 over x, if you find the inverse of 1 over x, you're just going to get 1 over x. So they're equal. Likewise, if you put f of x inside of itself, like if you have 1 over x, that's putting it inside, it's just going to be equal to x. We can see that that looks like there'll be 1, let's do it the full thing. That's 1 divided by 1 over x, which is the same as saying 1 times x over 1. And that's just x over 1, which is just x. And there we go. If we have a composite function inside itself of a reciprocal, it just equals x. So this property can be used to show that functions are self-inverse. If we use this function, that is showing us that it's self-inverse. So you could use this, you could find the inverse and then show that it's equal to f of x, or you could put the function inside of itself and show that it equals x. Those are both valid methods that you could do. Then we get the rational function. So that is when we have a linear function in the numerator and a linear function in the denominator. And these are having the exact same shape as a reciprocal function, but they just are going to have different asymptotes. So we have let me write it here, let's say y equals 2x minus 3 over x plus 1. Then, well, let's do this one. So our domain is going to be whatever is in this denominator, the number that we cannot have. So we cannot have 0 being in the denominator. That doesn't mean x can't be 0, because if we say that that's 0, we have 0 plus 1, and that's fine. We can have that. But if this was minus 1, then minus 1 plus 1 equals 0, and that is not possible. So we say x does not equal minus 1, because then our function can't exist. And we also say x is an element of real numbers. Then for our range, we are having to look at let's actually do the asymptotes at the same time. Asymptotes. Actually, so our vertical asymptote is whatever our domain is not, our vertical asymptote is. So x equals minus 1 is our vertical asymptote, but our domain is that x does not equal minus 1. Then for our horizontal asymptote, we're going to be taking the coefficients of the x values. So we have 2 here, and this is 1x, so 2 over 1. So that means our horizontal asymptote is y equals 2 over 1, which is just 2. So that's how we get our horizontal asymptotes. And if y equals 2 is our horizontal asymptote, that means y does not equal 2 is our range. Sorry, that should be y. In your exam, they will ask for the equation of the horizontal asymptote or the equation of the vertical asymptote. It is super important that you write x equals the number or y equals the number. If you just write the horizontal asymptote is 2, you will not get a mark for that because they said write the equation. So you have to write y equals 2. And make sure you get them the right way around. So horizontal is y and vertical is x. And once we have our vertical asymptotes and our horizontal asymptotes, we can start graphing it. So let's try with this one. This is a very common type of question where you have to find the intercepts, find the asymptotes, find the domain and range, which are linked to our asymptotes, and then graph it below. So let's start with the intercepts. So let's do when x equals 0, that's going to be our y-intercept. So let's substitute x equals 0. 2 times 0 minus 3 over 0 plus 1. So that just equals minus 3 over 1. There we go. So our y-intercept, let's write it, is 0 minus 3. I'm going to put that in a box for later because we will need it. Then let's do y equals 0. So in place of y, we put 0, 2x minus 3 over x plus 1. Multiply by x plus 1 on the other side is just 0. So we get 0 equals 2x minus 3. And then solve this equation. That's going to be x equals 3 over 2. So that's our next coordinate. We have x is 3 over 2, or 1.5, and y was 0. So that's our second intercept and coordinate that we have. Insert one. There we go. So we'll keep those for later. Now, our asymptotes. So what value for our vertical asymptote? We want to know x now. What value of x can we not have? Well, we cannot have minus 1. Then for our horizontal asymptote, we take the coefficients of the x. We do it like that. 2 over 1. So it's just 2. And remember, y equals 2. And then domain and range. Well, if our asymptote is x equals minus 1, then our domain is that x does not equal minus 1. And x is an element of real numbers. Just always say that. And then range. Well, our horizontal asymptote is y equals 2. So our range is y does not equal 2. And y is an element of real numbers. I found the vertical asymptote by thinking about what value of x I cannot have in my denominator. So the value of x that will make this denominator equal to 0. And the value there is minus 1, because we'll have minus 1 plus 1, which equals 0. And that we cannot have. So the vertical asymptote in all kinds of domain, actually, is whatever value you cannot have in the denominator, or if you have like a square root function, x minus 2, for example, you cannot have a negative number in here. So whatever value of x makes this negative is not possible. So vertical asymptotes for these functions are always what value of x can you not have in the denominator. So you can look at another one as well. Let's say 2x plus 3 over 3x minus 6. Whatever value of that we cannot have in the denominator. It might not always be obvious when you look at it, but you could put it like this and solve it like an equation. You're saying what value of x makes this equal to 0? So then we solve it like an equation. 3x equals 6. Divided by 3 on both sides, x equals 2. So then we know x cannot be 2 because it's going to make that denominator equal to 0. So x does not equal 2. Okay, so we found our intercepts, we found our asymptotes, our domain and range, and now it's time to graph it. Hope we can still see that. Okay, so the first thing that I recommend you do is we graph our asymptotes. So take a different color and just always do them with a dotted line so you don't confuse them with your graph. So let's do dotted line at x equals minus 1. And then label it, x equals minus 1. If you're an AISL, you can always graph it on your calculator and then just copy it across. And then y equals 2 is maybe somewhere here. Y equals 2. And then we have our intercepts. They might be on the same branch, like in the same quadrant. So if we have a look at the coefficients of our x, they are both positive. So that means we're going to be in this quadrant and in this quadrant. If one of the coefficients of x, just one, because if they're both negative, that makes it positive. But if one of the coefficients of x was negative, you'd be in these two quadrants. But we're in the positive quadrants. So let's plot our coordinate. Let's do our graph in red. So we have 0 and -3. So if we think about this, that's why it's important to have to remind yourself of what that is. That's -1. So -3. I know we're on 0 -3. So sorry, 0 -3. So I write my coordinate correctly. That's not in the right quadrant. 0 and -3, that would be there, but we're in... Okay, let's trust the process. Just thinking, did I have a negative? That was not meant to be somewhere. -3. No, that's definitely correct. And 1.5 and 0. So 1.5 and 0. Oh, no. I'm in the right quadrant. 1.5. Say that that's there. So here you can see that both of my coordinates are on one branch. So then there's going to be another branch here that's just going to be hanging in the air and it's not going to have any. So now I can draw in my line. Over there. And remember, we're getting closer and closer to our asymptotes, but we're never reaching it. And there. So this one is just hovering in its own area over there. All right. So we have graphed it. We found our intercept and our domain range and asymptotes. Very common type of exam question. Then sometimes you will be asked to transform it or have it in this form. So we can have, in the previous one, we had in the form f of x equals ax plus b over cx plus d. And that is the same as this one. So that one can equal that one. We just have to transform it a little bit and change the form of it, which I will show you how to do. Because sometimes they'll give it to you like that, and sometimes they'll give it to you like that. If they give it to you in this form, we still have that will be our vertical asymptote. So whatever value there makes it be impossible, then that would be our asymptote. So let's say we have f of x equals 2 over x minus 4 plus 10, for example. So I would still have in this form, I would be able to read that my vertical asymptote is x equals 4, because that's the value there that would make this 0, 4 minus 4. Then for my horizontal asymptote, I'm no longer looking at the coefficients here. It's whatever this number is that's being added or subtracted is going to be my horizontal asymptote. So that's positive 10, so it's just y equals 10. If that was negative 10, then this would be y equals negative 10. So that's another way that you can read them off of the graph. So let's look at how we can go from this form to this form. So if I start with this one, let me write this so we can check it later. The vertical asymptote here was x equals minus 1. And the horizontal asymptote here was y equals 2 over 1, right? So just 2. And then we can check that when we get to it later. So now we want to take it from this form into this form. So there's a little method for that. Let's say how that looks. Okay, so the bottom is x plus 1. So what we want to try and do is turn the top into having a factor of x plus 1. So I'm going to factor out 2, and because I want to get x plus 1, so I'm going to write x plus 1. And now I need to turn this numerator, now that I've factored that x plus 1, into still looking like that, to still be 2x minus 3. So if I think about multiplying this out, this is 2 times x, which is 2x. That's good. That's what we want. Then I have 2 times 1, so that's plus 2. I'm getting plus 2 here, but what I need it to have is minus 3. So if I have plus 2, I need to do something that's going to get me to minus 3. So what do I need to add or subtract to get to minus 3? Well, I need to minus 5. If I get a plus 2 here, I need to minus 5. And that will give me the minus 3 that I need there. So I write minus 5. I know this looks a bit weird, but hopefully it makes sense once you see it all together. So let me just show you this multiplied out. It's going to be 2x plus 2 minus 5, which gives me 2x minus 3, which is our numerator. That's what we wanted. So I've just rearranged this slightly. It's kind of like completing the square that we have seen in quadratics. So basically factor out the coefficient of the x and then just write the denominator because we want them to cancel out. And then whatever number we need to correct it. Just gonna get rid of that. Why is that not working? So let me take that out as well. So what this does is then we can separate these two. We can say 2x plus 1 over x plus 1 minus 5 over x plus 1. So we've just separated the two numerators over the denominators. And then we can cancel out that factor. That's the whole point of this. So that just leaves us with 2 minus, and then 5 over x plus 1. And there we go. We've transformed it into this form. So now from this one, we can read our asymptotes as well. So here you can see the denominator hasn't changed. The vertical asymptote is still x does not equal minus 1. In there, we can't have a minus 1. And now remember, this was whatever we were adding or subtracting was going to be our vertical, horizontal asymptote. So it's 2. So y equals 2. Yes, there's a negative there, but that negative is not for the 2. This is a positive 2. And check it. It's exactly the same as we had for when we looked at this one. So that's just a little method for how we can turn any function like this into a function like this. So we call that going from the rational form to the reciprocal form. So you can turn any rational function into a reciprocal function. Okay, let's do some exam style questions. There is another one of these later, just in case that didn't make sense and you want to see that happening again. There is one coming up later in an exam question. All right, so we have a function. It is in the rational form. They say find the 0 of f of x. So the 0 of f of x means that we need to find the x-intercept. So 0, solution, x-intercept. What other terms do we have? Zeros, I know they said 0, but zeros, solutions, x-intercepts, they're all the same word. So we need when y equals 0. So the 0 of f of x. Ooh. So let's write our function here. So when that is equal to 0, we can solve 4x. Multiply by this on the other side, so we get 0 equals 7x plus 4. And that will give us 7x equals minus 4, so x equals minus 4 over 7. So we have, I'm just going to take out, neaten this up and write it there. The 0 of f of x is that x equals minus 4 over 7. That's our x-intercept. Can keep this here for later. Technology and me are not winning today. Sorry. Okay, I give up. It's just not wanting to listen. So that's the working for A, and then I'll do the rest over here. Okay, for B, Write down the equation of the vertical asymptote. So vertical asymptote is x, horizontal asymptote is y. So here, notice again, they say the equation, that always needs to be an x equals. Please don't just write the number. So we have 2x minus 4 in the denominator there. So 2x minus 4. We need to figure out what value of x will make that 0. So let's solve the equation. And so it's x equals 2. So the vertical asymptote is x equals 2. Horizontal asymptote is taking the coefficients of, let's do it in green, of these two, the coefficients of x, so 7 over 2. So y equals 7 over 2. Then find the inverse function, f of minus 1 of x. So we need to find the inverse. And this is great practice because there's a slightly extra step when you're finding the inverse here. So that's great practice. So I want to find the inverse of this function. So when you're finding the inverse, write it as y equals. So you have it in terms of x and y. And what we're going to do is we're going to try and get x to be the subject of the equation. So you could either switch x and y and then make y the subject again, or you can first make x the subject and then switch. Both are the same. So let's keep them and try and make x the subject. So I'm going to multiply by this denominator over here. So 2x minus 4. Is it not plus 7? Plus 7. Sorry, what do you mean plus 7? Which question was that for? Here we have 7 over 2 on A. So the 0 was finding the x. So we had 7x plus 4, and then we move, I moved minus 4 over to the other side, or plus 4 over to the other side, so it became minus 4. So then we have minus 4 over 7. I'm not sure if... Oh, I see what you mean. I did a miswrite. Yes, I see what you mean. Great catch. For some reason, I wrote plus 4 there. And so, let's just go. By the way, if you do a miswrite in your exam, yeah, thank you for catching it. I bet you're wondering why on earth did that become plus 4. But if you do a miswrite like I just did on your exam, you actually can still get the marks because they will notice that it was a miswrite and they will carry on with that. So that's a good thing to note just in case that happens, but obviously double checked. Thank you for catching that. So then we have 7x equals minus 7. So x equals minus 1. Nice. All right, so we were finding the inverse over here. So I just need to make sure that's not covered by my camera. Thank you. So we multiply by 2x minus 4 on this side. So 2x minus 4, let's keep brackets, times y equals 7x plus 7. And just the first time that you see this, if you haven't seen it before, it might seem like a bit of a weird method, but it's always going to be the same. Whenever you're finding the inverse of a rational function, it's always going to be this method. So once you've done it twice, I think it makes more sense. Okay, so we multiplied over, then let's multiply out the brackets. So we have 2xy minus 4y equals 7x plus 7. Now I want to move all my x terms to one side and all my y terms to the other. So x terms on the side minus 7x and my y terms to the other side. So 7 plus 4y, moving that one over. Now, because I want it in terms of x equals, that's what I want to end up with, I need to turn these two x's into one x. So I'm going to factor x out of this. So if I factor x out of these two terms, I'm going to be left with 2y minus 7 equals 7 plus 4y. Now I can divide this whole bracket on the other side, so I'm just left with my x equals. That's what I wanted. And so that is 7 plus 4y. It's quite a common question, by the way. They love to ask you to find the inverse of these functions because it has this extra part where you have to factor them out. We just need to wait for my computer to catch up. It's not having a good day today. It's just hovering in the ether. Hello, come back. Let's try that. There we go. I don't know why that happens. I think it's just a bit of an overload. All right, so now we have it in terms of x, which is what we wanted. And now finally we can switch the x's and the y's. So we have 4x plus 7. I'm just writing it with the x term in front. And 2x minus 7. There we go. And now that is our inverse function. And don't forget to write it finally with this notation. F of minus 1 of x equals 4x plus 7 over 2x minus 7. So we could have done the switch first. I could have switched x and y here and then done that whole process and just already been in terms of y equals. You'll get the same answer. So both are correct. And there I've answered all the questions, I think. Yeah. So let's take a look at the mark scheme. So don't forget you're getting lots of method marks here for things like recognizing and attempting. So recognizing, so make sure that you're showing you're working. Recognizing f of x equals 0 because that was the 0. Find the 0. That was the command term, find the 0. So they are wanting to check that you know that f of x equals 0 is what this little command means. And we got x equals minus 1. Then, see, must be an equation with x, must be an equation with y. So please, when they ask for an asymptote, don't just write 2. You must write x equals 2. And with x and not y. What else? They're working to find the inverse, just some method marks there, a couple of different ways to do it, like I said. And then finally, you get your inverse function. So don't forget to have that notation there. Okay, let's try another one. Do you recognize this form over here? This is in our, it's a rational function that's in reciprocal form. So now we have to recognize the vertical asymptotes and horizontal asymptotes from this form. So for the vertical asymptote, it's always just this. What number can we not have in our denominator that will make it 0? So the vertical asymptote is going to be x equals, and again they say equation. It equals 2. We can't have 2 because then we'd have 2 minus 2, not possible. Horizontal asymptote, y equals, it was whatever value we were adding onto the function. So this is a positive 1, not to be confused with that negative there. So y equals 1. Lovely, easy 2 marks there. Find the coordinates of the point where the graph intersects the y-axis and the x-axis. So what that means, where they intersect, is just saying find the x and y intercepts. So let's go ahead and find the intercepts. So let me write the function down here to do my working. F of x equals 1 minus 1 over x minus 2, and double check that I wrote it correctly. Yeah. So where it intercepts the x-axis, that means let's find when x equals 0. 1 minus 1 over minus 2, because that was just 0. So let's simplify that a bit. That minus and minus makes plus. So it's 1 plus a half. 1 plus a half is 3 over 2, or 1.5. So where it intersects the y-axis is at the, and it says coordinates. go ahead with your highlighter before the question and highlight how they want you to leave it. They don't just want 3/2. If you wrote 3/2, that's 1 mark you would not get because they want coordinates. So there's no room for mistakes there. So coordinates would be x was 0 and y was 3/2. Now for the x-axis, we need when y equals 0. So we have 0 equals, I should just draw a line there so you know I'm not following on from that. 0 equals 1 minus 1 over x minus 2. And now let's solve this. I'm running out of space. Let's move 1 over to the other side. So then we have 1 over x minus 2. Then I'm going to multiply x minus 2 times that 1. So that's x minus 2 equals 1. You should never work across like this, always down. I'm just running out of space. So x equals 3. Okay, so we have 3 and 0. If anything there didn't make sense, just let me know. I moved that over to the other side, so they're both positive, multiplied by x minus 2 on this side, and then solve the equation. So x equals 3. There we go. We've got our asymptotes. We've got our intercept. So now we're ready to graph the function. So let's plot our asymptotes first. Let's do them with this. So we have at x equals 2 and y equals 1. So there's x equals 2 and y equals 1. Now they are not very generous in this because there's only 1 mark for this whole graph. And another thing, if you've not been in these sessions, when they say sketch, it means roughly. It doesn't have to be perfect. But they have given us the axes, so that's nice. So x equals 2 and y equals 1. Double check that that is correct. And then we can plot our coordinates and then we can graph. So 0 and 1.5, that was 0 and 1.5 is there. Maybe I'll do a different color. Okay, so that's going to be on this branch. And then 3 and 0. 3 and 0, that's here. So we have 2 branches. So that is going to go through there. Okay, I just saw a question and I'll show you that in a second. And this one going like there, and it's always going across but never reaching that asymptote. And there we go. We have our points, we have our asymptotes, and we get that only 1 mark for doing all of that. But still, all the marks that we can get, the better. So your question, how could we get the graph in the calculator if asked? So I would take this graph and I guess you mean how to graph it on the calculator. So I would take this 1 minus 1 over x minus 2. Let's graph it. So and this applies to any question. I want a new document. I do not want a stopwatch. Sorry. There we go. All right, and our graph was 1 minus, let's do a fraction, 1 over, oops. Oh gosh, these calculators. X minus 2. There we go. Okay, so that is how you graph it, but the axes are all over the place. So what I would do if I were you, if I'm asked to graph it, I would then look at what scale they give us, like what numbers. So they've given from -5 to 5 and -5 to 5. So to make sure you're going to draw the most beautiful exact graph, I would change the window settings to be -5 to 5 and -5 to 5. And there you can see the exact graph, how it should look. So there we go. See, it's more on a little bit more on this side and this side. You can see the asymptotes are there and there, and seeing as it's a sketch, it's okay to have it quite roughly drawn. So this is exactly what you should copy out onto your paper. If you have a calculator in your exam, so for AA paper 2 or for any AI paper, just note what they give you until and change that to be your view. So you don't even have to think about it. You just copy exactly what you see. Make sure that it reaches the end points around the same place. That's important, that it's not too rough. Should still be quite accurate, but doesn't have to be like perfectly sketched. All right. So we had to see the mark just for the equation. So if you just wrote 2, you wouldn't get it, the equation. Then our coordinates, 1 mark there, and then here. So 2 correct branches with correct asymptotic behavior. So your asymptote showing that it's reaching but not getting. You're welcome. And your intercepts clearly shown. So you should also write the coordinates of your intercepts. Okay, let's try. I realized that we started a bit late because I was doing this session on another stream without realizing. So we have run out a little bit of time there, but I think I will go a little bit longer just to do one more question. Again, massive apologies for that. I've done 16 of these sessions now, and I've never done that, so not ideal. But well done for still being here. So we have the diagram that shows the graph of this rational function. It passes through those points over there. Just to note, those points are not the asymptotes, are not the intercepts, but they're just 2 points on the graph. So that's some key information that we're going to use later. So that's one set of coordinates, and that's one other set of coordinates. So we have an x and a y. This should hint to you that you're probably going to get a simultaneous equation that we're going to have to solve. And indeed, we have 2 unknowns, a and b. So first question, determine the value of a and the value of b. So we're going to need simultaneous equations. Let's set them up here. So y equals ax plus b, x minus 4. So let's insert point p's coordinates. So in y is 1 and x is minus 10. So a times minus 10 plus b over minus 10 minus 4. So that's minus 14. Okay, that's our first one. Then let's do maybe q over here. So we have minus 12 equals a, no, x is 3 plus b over 3 minus 4. Now let's simplify now that we have those. So that minus 14, I'm going to multiply on that side. So I do not like fractions. Minus 14 equals minus 10a plus b. Okay, already that's looking a lot friendlier. Should I highlight it in a box so it's super clear? Then this one, that's 3 minus 4, which gives me minus 1. So I'm going to multiply minus 1 on that side. That's going to be positive 12. Positive 12 equals 3a plus b. And now it's just a friendly set of simultaneous equations. There we go. Which I'm going to solve. So let's put them neatly together. We have minus 14 equals minus 10a plus b. And 12 equals 3a plus b. So the coefficients of my b are the same. So I can subtract either one of these to get rid of the b's. And what you should do, good practice, is to label it equation 1 and equation 2 and show your examiner what you're doing. So I think I'm going to do equation 2 minus equation 1. There are no wrong answers here, just easier answers and more complicated steps. but same answer. Okay, so equation 2 minus equation 1. And maybe I'll just write so then you are aware of what you're doing each time. Minus, minus, minus. So 12 minus 14. So that actually means 12 plus 14, which is 26. Then 3a minus 10 means 3 plus 10, so 13a. And b minus b, 0, which is what we wanted. So you can see a equals 2. How nice and neat. Now to figure out what b is, let's substitute for my second equation I prefer because it has less negatives. So 12 equals 3 times a, which was 2, plus b. So that's going to be 12 equals 6 plus b. And there we can see b equals 6. So now we found the value of a and of b. Done. Describe a sequence of transformations. This is a 5-mark question. A sequence of transformations that would map the graph of y equals 1 over x onto this graph. So what they're saying is when this is a reciprocal function, how did it come to be this kind of function? And how we want to see that is from that form that we had earlier when we had a over, not the same a as that one, x minus h plus, let's say, k. So when it was in that form, we can see how it differs from this because you can see how much it's moved left or right. You can see the vertical stretch factor and how much it's been shifted up or down. In this form, it's not as easy to see. So we have to take it from this form to be able to see the transformations. So let's write our function all together now that we know our a and b. So let's maybe do it here, b. So our function was y equals ax plus b, so y equals 2x plus 6, just substituting in our a and b, and over x minus 4. Right, so from this form, we want to get it into this form. So do you remember how we had to split it? We're going to need to do a factor of x minus 4. So I'm going to take 2 out, the x minus 4 is staying. I'm going to take factor 2 out and then write in my denominator x minus 4 because I need to have that. All right, so now if I multiply this out, I get 2x minus 8. So I'll write that up here. 2x minus 8 when I multiply that out. And I need to have 2x plus 6. So what do I need to add or subtract on here to make this equal to 6? Because that's what we have, plus 6. I need to do minus 8 plus 14. If I have minus 8 plus 14, that's going to give me 6. So plus 14. So we can check 2x minus 8 plus 14 is going to give me 2x plus 6. And now I can separate it. So I have 2 over x minus 4, plus 14 over x minus 4. Just split these two terms over my denominator. These cancel out, which is what I was wanting, what we want every time. So that is 14 over x minus 4 plus 2. Just put the 2 plus 2 on that side, just so it's in that form. And now you can see from the graph of y equals 1, no, that's not what I meant. We want u. From y equals 1 over x to this graph, we can see what's changed. So let me highlight that. We have a minus 4, we have a 14, and we have a plus 2. Those are the sequence of transformations. And when we're listing the sequence of transformations that happen, we do them starting from the x and working our way out. So if we start from what's happening to the x directly, so the first one is that we got shifted 4 units to the right. So the nice way of saying that is translation of 4 units, and you have to say left or right. You can't just say translation of 4 units because that could mean up or down as well. Translation of 4 units right. If it's negative, you're actually going right. Then the next thing that's happening, we call that a vertical stretch of 14. Stretch of factor 14. And then the last one, we had a translation of 2 units up, because it's positive, so 2 units up. All right, and those are our sequence of transformations. Right, and that was a lovely 5 marks. So for just changing that form from the rational form into the reciprocal form, and then describing each of those transformations, lovely 5 marks. Not a very hard question, but it might seem like it is a lot, but there's a lot of marks going on in there that are not too difficult to get. So I think the most difficult part of this question would be recognizing that in order to answer it, you need to transform it into this form. That's how you can see the transformations. Okay. So in the mark scheme, we solved our equation simultaneously. Again, you get marks just for an attempt. So that's really nice. You really show your methods. Again, attempt. And then, yeah, we had our... There were many different ways that you could say these translations. So you could put stretch scale factor 14, and you could write the translation like this. That means 4 units to the right and 2 units up in vector form. That's also fine. Okay, so I am going to stop there because we are quite out of time. But as usual, if you would like these session notes and more exam past paper questions, just feel free to DM me on Instagram with your email address, and I'll share the folder with you. And then we also have homework questions, like little homework tasks for session 16, which I will put on after this. And there's plenty of notes as well to help you. And yeah, a couple of exam tips that you can go through. I think we talked about all of these already. So if you just want those, this is on every single session we've had. There's exam tips and common mistakes that you could go through. So yeah, feel free to reach out. All right, any questions? I hope that made sense. The biggest thing I can remind you is to write your asymptotes as equations. And remember which one is X and which one is Y. That's the biggest thing that I see students making mistakes with in the exams. Just give a moment in case anyone wants to type anything. Don't forget that if it is paper 2 for AA, or if you're an AISL, that your calculator is your best friend. So when in doubt, use it. I would always favor doing things on the calculator rather than algebraically, because the calculator is less likely to make mistakes. And it saves time as well. Okay, if there are no questions, then I'll end there. Thank you for joining, and I hope the studying is going well and you're not feeling too stressed. If you have any maths questions at all, like I've said before, please feel free to DM me. I'm happy to help and answer questions. Okay, no questions, I think. Well, have a lovely rest of your evening, and see you at the next one tomorrow, possibly, where I will this time make sure that I click on the right link. So, goodbye.